Hi everyone. So today I'm going to show you how to do the assignment question for RE1.3. The common mistakes that I see is number one, failure to define the positive direction. It is very important to define what is the direction of the direction that you're taking to be positive. So I'm doing that now. Second mistake that is very common is failure to define correctly where is the starting point and the ending point that you want to analyze. So for example, in part A, how long does it take to reach the bottom of the cliff? We are looking at a starting point here. The ball will be thrown up and you ultimately reach here. So this will be the ending point. So with these ending points and starting points defined properly, you will know that your initial velocity is here and your final velocity is here. So writing out all the variables. You do not know about the time interval, you have to find this. The displacement is actually a downwards displacement, in which case it will be negative 70 meters. Be careful of the negative sign. Acceleration is always downwards and it's negative 9.81 meter per second square. Velocity, the final velocity is unknown, and the initial launching velocity is upwards at positive 12 meter per second. With this, note your presentation, always state the equation first. So I'm going to use this equation today, plus half a t squared. If I plug in all the relevant numbers and I solve it, which I will skip for now, I should get two time values, one to be rejected because it's negative, and second time value of 5.198 second. Corrected to 3SF, it will be 5.20 second. So for part B, we will use back the same diagram, the same starting point and ending point, and therefore our table of quantities will still remain. So to find the final velocity just before the ball hits the bottom of the cliff, I will use this equation: v squared equals to u squared plus 2a displacement. So if I plug in all the values, I should get v equals to two roots, one positive and one negative, 38.9538, in which I should choose the negative velocity corrected to 3SF. Negative because the final velocity is going down and downwards is negative. So my final velocity is 39.0 meter per second downwards. Now for part C, we are supposed to find the total distance that the rock or the stone travel. So we already know that the cliff is 70 meters above the bottom of the cliff, and therefore we need to find what is this maximum height. And if I take this maximum height and I add it again to the maximum height and I add it to this 70 meter, I'll get the total distance. A common mistake here that was committed was some students only added 70 meters to this value. We should have added 70 meters to twice of this height. So let's go about to find this height over here. Therefore, I need to redraw a new diagram. This will be my starting point as per usual, but my ending point will be somewhere here. This is U, this is V. Recreating the table of quantities, my time interval is unknown. My displacement, it should be an upwards displacement. So I need to find this. My acceleration is still the same, downwards, negative 9.81 meter per second square. Final velocity at the top of the throw will be 0, and my initial launching velocity is positive 12 meter per second upwards. I will use the equation v squared equals to u squared plus 2a displacement, and plugging in the numbers, and before that rearranging the equation to make displacement the subject of the equation, I will get 7.3394 meters. So I have a maximum height of 7.3 meters. It comes down 7.3 meters again, and it further travels downwards for 70 meters. So my total distance traveled will be 2 times of 7.3394 plus 70, and I should get 84.7 meters.